Thank you. Thank you, Itai, for that warm introduction. Um, yeah, so as he said, I'm going to be talking about RAG, Retrieval-Augmented Generation, which is a kind of tool system used in a lot of artificial intelligence products and models to kind of connect ChatGPT or any other large language model to your documents. Before I kind of go into the details, I just want to quickly ask, who's been at the Bethesda Data Science Meetup before? Okay, so that's good because a bunch of you have and a bunch of you have not. So I've actually created a little demo that I'm going to show before the slides, where I'm going to kind of give an example of a RAG tool. And specifically, it's going to be asking questions of previous Bethesda data science speakers using ChatGPT. A bunch of these talks have been on YouTube, and I was able to access that. And who was here over the summer? There was a talk about social engineering. Were people there for that? Yeah, so people were there for that. So social engineering, actually, let me just quickly ask, what is social engineering? And this tool is going to, I'm submitting the question, asking the AI about what is social engineering. And it says that social engineering is described is basically manipulating people to get them to do things. It can be a positive if you're trying to manipulate them for their own benefit, or negative if you're trying to harm them. One of the things that the speaker there spoke about is how to identify if you are being socially engineered. Term was, how do you know if you are the mark? So I'm going to ask, based on the talk, how do I know if I am the mark? And I'm able to ask my tool, kind of going into the talk, it's asking the transcript of the talk, and it says you should look for some red flags, flattery, inconsistent stories. One of the cool things about this RAG method is it's able to really find where you got it from. So this has, this has the video from the talk itself. And this was sort of the section in the video where, in the talk, where he kind of answered that question. You know, I have a bunch of the recent talks. I know there was a talk at one point about Dask, and I actually wasn't able to attend it. I don't know that much about Dask. I know it has to do with being a replacement for pandas, which is a Python package. And I might want to ask, when would I use pandas, Dask instead of pandas? This was a part of the discussion. And this is going to ask, hold on. You would use Dask instead of pandas when you have larger than memory data sets. So this is sort of just some examples of how you can use RAG to ask questions of the document. You might be saying to yourself that all of the information that I've mentioned is actually probably in ChatGPT itself, so it's not that special. But just to show how it's looking at the specific documents, there was a talk about Streamlit, and I don't know if anybody was at that, but it was based on a hackathon. So I'm going to ask what happened in the hackathon, and it is specifically going to sort of answer here. Hold on a moment. During the hackathon, the team representing MoCo makers and HackDC tackled drug discovery for neurofibromatosis. So this is something that's actually definitely not in ChatGPT. This is kind of a way where it's actually literally asking from the talk all of kind of these questions. It can talk about the prizes that were won. I think at this point, I'm going to pause and go back to the slides. So I'll just start off with an introduction. Who am I? My name is Alan Fader. I'm a data scientist. At the moment, I'm looking for a new gig. So if you have ideas, come speak to me after. I am also working as a part-time adjunct professor teaching business analytics at the University of Baltimore. I live right around here in Montgomery County, about 10-15 minute drive away. But until recently, I've been living in New York City my whole life, where I'm from. And I get really excited about natural language processing and machine learning. So again, as most of you probably heard of the term language models. Language model itself is an algorithm that predicts the next word, the next likely sequence of words. It takes sort of a set of words, either from a question, the question is sometimes called the prompt, and it then predicts each next word sequentially. Generally, language models are probabilistic and stochastic, meaning it's random. You might get slightly different answers every time, and it's not sort of set rules. It uses historical data about texts to sort of predict what's going to happen. Until, say, 4 or 5 years ago, they had been used a lot for machine translation or summarization. But frankly, until, say, 2018, 2019, they didn't really work very well for all except for very precise and specific use cases. And that's what leads to large language models, which is just like a language model, but larger, more data, bigger architecture, more computing power. There's a lot of complicated terminology that you might hear if you look at large language models, like attention and transformer. I'm not going to be talking about that type in this talk, but about a year and a half ago, there was a talk about BERT at the Bethesda Data Science Meetup. So you can kind of link to some of the slides there if you're interested in learning more. But of course, the reason that everyone came today is because people have heard of ChatGPT. I should have taken the screenshot from today. As Itai said, today is ChatGPT's first birthday. Actually, on the screen, there was a little birthday cap above the ChatGPT logo. If you checked it today, ChatGPT is an amazingly impressive chatbot. You can make up a story about Sharky, a toothbrushing shark. You could ask ChatGPT to write a poem about tying your shoes in the style of a Shakespearean sonnet. You can have conversations with it. Probably some of you have had it do your homework for you. It can really be doing a lot of cool things, but as everybody knows, there's a big danger to it, and it warns you on the bottom. ChatGPT can make mistakes, and it does. If anybody's used it for more than a little bit, you've probably run into some of its mistakes, which is often called hallucinations. There was a pretty story that got around a lot about a lawyer who used ChatGPT for their kind of legal filings, making up where ChatGPT hallucinated certain case law. And when the opposing counsel tried to find it, they realized it didn't exist, complained to the judge, and the lawyer was fine. It makes other mistakes. One of my favorite ones that I find really funny, I asked it to find mathematical similarities between numbers 4 and 37. This one I was using a Google large language model called BARD. It taught me interesting facts, like both 4 and 37 are prime numbers. Who knew? Apparently 4 and 37 are divisible both by 11, which might contradict the first point and is not true. I'm pretty sure each of these points are not true. It was like, actually one of them is true, but basically all of them are not true. And it's really funny. And if you didn't know much about math, you might not know. ChatGPT also doesn't know everything. I asked it the same question I asked my RAG Streamlit app earlier in the Bethesda Data Science Meetup over the summer. What did the speaker say would let someone know that they are the mark? And it says it doesn't know. It doesn't know what happened in the Bethesda Data Science Meetup over the summer. It actually says you should really reach out to the organizers of the Bethesda Data Science Meetup. So Itai, people might come to you, but ultimately, part of it is we don't even know what data is used to train any of these large language models, especially the OpenAI one, which isn't particularly open. Even if it was using, say, transcripts of YouTube videos, which it may or may not be, you would never be able to recover one specific document from there. There are so many millions of documents that you can't capture any specific one. And that's what leads to the need and excitement for retrieval-augmented generation, also quickly called RAG. So RAG is a way that combines an output of a large language model with information retrieval from some type of external source. It retrieves a list of documents to identify which ones are likely to have the answer to your question. And then the large language model uses only those documents to generate the final answer. One of the nice things is because it identified documents, the final output can actually link back to the documents for verification. RAGs can be used in a number of ways. One of the ways people are talking about it a lot is for something like HR benefits, customer support, tech support. You could imagine if you work for a large company that has a super long benefits document or some type of HR rules, and you want to ask it and you don't want to read through on your own a dense 75-page PDF, you might be able to ask some type of RAG model about your question, and it might give you the correct answer. You could do it for tech support about maybe a new product that you have. There's some more exciting, possibly a little bit scarier methods about using it for medical device. There's actually a paper that I have the link to called where the authors made Almanac, which is their version of a RAG using medical, kind of dispensing medical advice, using up-to-date medical research, way better than ChatGPT. Reading through the paper, I'm a little bit concerned that it's still not quite as good as an intelligent, knowledgeable doctor. So I wouldn't go use it just yet, but it's getting there, and it really could actually probably help somebody who's already a medical professional do their job a little bit more quickly. I also imagine that legal research services like Westlaw or other type of stuff, I'm sure that many of them are working on developing this for their own sort of body of work. So I'm going to talk a little about some of the theory behind RAG, and this is where we kind of get to prompt engineering. This is a term many of you have heard of. There were all these articles a few months ago about how prompt engineer is a new job where you make lots and lots of money and you don't really need any training. I've been looking for a job for the past few months. I have not seen any prompt engineer jobs, so I'm skeptical that this is something real. But prompt engineering is actually a real skill that you can use. Andrew Ng, who is one of the leaders in machine learning, he's one of the founders of the concept of massive open online courses, actually has a course on his deeplearning.ai website about how to do ChatGPT prompt engineering in your tools. So it's something that, again, people are really using, whether or not it's its own job. Prompt engineering, what it does is it kind of teaches you how to tailor the prompts, meaning the question that you're putting into ChatGPT, in a way that's going to get accurate and relevant model responses. Some of the most important points of prompt engineering are context inclusion and showing it how to give a specific output. So these are slides that I made a week and a half ago, when this was there was a lot of drama going on with the leadership of OpenAI. If anybody was following, I asked a language model, specifically Claude, the language model from Anthropic, which is a competitor, why was Sam Altman fired from OpenAI? And it said, I don't know. For all I know, Sam Altman is still the CEO. At that point, he wasn't. Now he is. But it knew a little better, but it really had no idea what was going on. I then went and asked ChatGPT. I asked the same model again, but this time I copied and pasted the text of a news article about it, and it was able to then read the news article and answer. It's not getting the answer from its vast knowledge base. It's getting it from the context that I put in. So this is a way that you can kind of put in your own context and explain. Moreover, you can tell the large language model how to say it. If you are a developer and you want to build this into a different tool, you can tell it how to output. You might want some type of JSON format. And I kind of gave it the example of which sort of JSON elements I wanted it to come out. And it did it. And I'm able to, if I was using this, I could take this and pipe this in to some other type of program that I'm building. Now, if we have that, why do we even need RAGs? Why can't we always just throw everything into the context window? There's a couple of reasons. For one, large language models only can kind of remember a limited number of words. Words in large language models are usually called tokens. You might hear that term a lot. A token is like often part of a word. Most words equals one token, but sometimes it'll be split. For example, the word modernization will be split into two tokens, modern and isation. And it sort of uses that to better understand what's going on as it's processing your text. And for example, Llama 2, which is the large language model put out by Facebook and is probably among the top of all the open source, freely available models out there, has a context length, meaning the total number of words it'll remember at any one time is around 4,000 tokens. So that might be fine if you have like, I don't know, a 4 or 5 page document at most. But often you might have a 50-page document, 100-page document. All of the YouTube videos that I put into the app at the beginning are all longer than 4,000 tokens. It won't remember it kind of all at one time. Even many of the sort of GPT-4, which is the top of the line model put out by OpenAI, that more recently has 128,000 tokens, which is pretty big. For one thing, there's been research that it's actually not so good at remembering what's in the middle of the 128,000 stuff. It's pretty bad at that. So you don't want your information to be there. But even separate from that, first of all, you might be looking through, I was interviewing somewhere where they had kind of hundreds and thousands of reports, each of which were fairly long. So that's going to blast out of the context window. But even more so, ChatGPT costs money. It's 1 cent. You pay 1 cent per 1,000 tokens you're going to use, which might not sound like a lot of money. But if you imagine that you have a company report that's 50 pages long, that might be 33,000 tokens, which is 33 cents per query. And maybe your company has 5,000 employees and people might start making multiple queries per hour. And soon enough, you're giving a lot of money to Sam Altman. The other kind of theoretical topic that I want to discuss before I sort of show people how to make a RAG is the concept of embeddings. In my opinion, this is one of the most important sort of natural language processing concepts that underlies all of these advancements that we've seen in the past few years. And all of these models sort of work on pre-trained embedding vectors. To sort of explain it at a simple level, we start with word embeddings. What a word embedding does is it sort of represents any word as a set of numbers. Each one is a dimension, can be anywhere from 50 to 1,500 dimensions. And every element of the vector represents something about the semantic meaning of the word. You know, you and I might hear words like cat, kitten, or king, or queen, or jump, or run, or really any word. And we immediately know from our many years speaking and listening what that word means. But in a word embedding, that's represented as a set of numbers. Because ultimately, machine learning is just math, and math works on numbers. And we really need a way to map our words, our ideas and sentences into a set of numbers so that we can math on it. Here there's an example of maybe one column or dimension in your database represents how much this is a living being. Maybe one of them is how much the word is a verb, how much of it is gender. Now, this is a way to kind of understand what's going on. Looking at an embedding, it's never, ever as simple as this. You're never really going to be able to look through and understand, oh, the 17th dimension is gender. That doesn't exist. But really, there are ways to ensure that your set of numbers, your mapping to numbers, represents something about the meaning and is a fair translation of the meaning. And one of the ways we do it is thinking about similarity. Thinking about words that are more similar, say synonyms, or words that are representing something similar, you'd expect the synonyms to essentially map to very similar numbers, very similar vectors to each other. And the way that we calculate that, one of the ways to calculate that is through cosine similarity. Because you could take a set of numbers, which is, maybe again, length, let's say 50 dimensions. And you can imagine plotting it in a 50-dimensional vector space, thinking about it in terms of physics or something like that. And if you think about plotting a point in a vector space, you could also imagine lines coming from the origin to those. And then you're going to have angles between those lines. If the angle between, say, the word to synonyms, you'd expect that angle to be a really small angle. If words are pretty irrelevant to each other, you might expect it to be close to a right angle. And that actually maps to cosines. If anybody remembers their high school trigonometry, where the cosine of a very small number is close to 1. And that is a good way of kind of representing, hey, a cosine similarity of 1 means these words are actually pretty similar to each other. Cosine similarity of 0 might mean that these words have nothing to do with each other. And a negative cosine similarity might mean that they're totally opposite. I asked DALL-E, which is a generative art model, to make a picture for word embeddings. And this is really hard to read, but actually I think that represents pretty well what word embeddings are. It's sort of lines coming out from some type of mess of points. This is generative art, so all the words there are gibberish, if any of you have used DALL-E. But ultimately, I think this is a fair way to think about what word embeddings are. But then, of course, we can embed our entire document or text or any type of text that we might put into ChatGPT. ChatGPT turns that into an embedding, into a set of numbers. In that embedding, each feature represents something about the meaning, and therefore documents that are about the same topic are going to have vectors and numbers that are more similar to each other through the cosine similarity metric. I know this is a little bit in detail. I'm just going to give two last examples because I think embeddings is a really important way to understand what's going on. I made a text about going to a Bethesda data science meetup where a speaker is going to be talking about RAGs. I asked OpenAI to embed it. And then you can kind of see here, it prints out, it created a length 1,536 vector. And then this is just an example of the first 3 elements of the vector. These are numbers. It's not really clear what they mean, but ultimately they are representing something about the meaning of this. I made another example where I have 4 documents. The first one is about a person, a person who's speaking about, someone who's going to talk about RAGs. The second one is about a person who has questions about ChatGPT. The third one is about the New York Mets baseball team. The fourth one is about the Baltimore Ravens football team. And when I take the cosine similarities of the embeddings of these documents, you can see the number of comparing the RAG and the ChatGPT is actually fairly high. The number comparing the closeness of the baseball, the two sports examples, is also fairly high. But the cross examples, comparing the texts about sports to those talking about ChatGPT, the number is a lot lower because they're about different topics. And this leads us to how to create a RAG. I'll go through this more in detail in a moment, but you first split and chunk your document, you embed your chunks, you embed your questions, calculate the cosine similarities, retrieve the best, engineer your prompt, generate your output, and show your proof. Step 0, before you can actually do any of that, is taking what you have and turn it into text. My example at the beginning, the app that I created is about YouTube videos. Actually, I didn't realize this until a few weeks ago, but all YouTube videos, at least the ones that I found, it has an auto-generated transcript. There, you can go and find it. You can also use a free package on Python YouTube transcript API to just download it for any YouTube video. The transcript is okay. I find that large language models actually often work well with okay transcripts. It's able to sort of split out the ums. It's able to figure out what they're saying. But that's kind of good and free. What I ended up using for this tool is a different tool called Reduct.video. It's a company that I actually found that the transcript was way better. Also, YouTube transcript API breaks things up into every, say, 5 to 10 seconds. Reduct gets the millisecond that somebody says every word. So it was a nice tool. It costs, but it kind of worked well for this. And if in general you're trying to build a RAG tool, LangChain is a package that has lots of add-ons and goodies for anything you're going to do. And they have connectors for almost any type of data that you're trying to bring in, including PDFs or anything like that. The next step into creating your RAG is to split your document, because your document might be too big for the window. And as we said earlier, we want to only find the most specific answers to your question. I find this to be one of the hardest parts. Part of the reason for that is there's not a great best practices on how to chunk documents. It really depends on the use case, the document itself. Ideally, you want something smaller, so you're getting something that's really exactly what you want. On the other hand, it's hard to find that, and sometimes you need added context. Depending on what you're going to do, sometimes you can break it down by chapter headings. If chapter headings exist, they often don't. What people often do is they kind of have subsequent splits overlap some space, because you don't want a situation where somebody's saying a sentence and that accidentally splits up. What I did in YouTube videos is I broke the transcripts into chunks of 1 minute, 15 seconds with a 15-second overlap, so that you can really find wherever you want where the person discussed it. You then, I talked about embedding your documents. You want to do that to each sort of sub-document chunk here. Any embedding model will do. OpenAI has its own embedding model. It's fairly cheap. This one is, I think, 1 cent for every 25,000 tokens. So I think in like all my YouTube videos that I did for my first thing, I only paid them like 5 cents total. So that's not what's likely to skyrocket your costs. But there's also SBERT, SentenceBERT, which uses sort of the previous generation of large language models, which were all named after Sesame Street characters. And it's really able to kind of create an embedding based on that. The nice thing about that is it's entirely open source. You're able to fine tune them and make them really about your topic itself. I just used OpenAI here. Once you've done that, you've taken your whole document, or maybe all 100 documents that you're using. You've split them up into, I don't know, 100 or 1,000 or 10,000 sub-document chunks, and you've embedded them. You store them somewhere, and then you're going to go and take the question prompt that you or somebody else is going to put into your RAG tool and embed that. Now you've got a situation where you have tens of thousands of embedding sets of numbers and a set of numbers for your question. And remember, we said that embeddings, the theory behind it is that these numbers represent something about the topic, the meaning of what you're saying. So if you think about it, you have a question about a topic and say that topic shows up in 3 or 2 of your many chunks. You'd expect your number, your set of numbers, to be fairly similar to just those 2 or 3 chunks. So what you're going to do is run the cosine similarity, the metric we talked about before, between your question embedding and every single document embedding you have. And again, what's going to happen is those with the highest cosine similarity score are likely to be about the same topic as your question, and therefore are likely to contain the answers to your question. From my demo at the beginning, I was able to ask, how do I know if I am the mark? There's going to be something about the embedding there that represents that, and it's going to be closest to the parts of the video where the person talked about, how do I know if I am the mark? It's not looking up word by word, but it is looking up the meaning. I want to quickly mention, if anybody follows tech business news, there's been a lot of talk over the past, say, 6 months of the concept of vector stores, vector databases. One of the big reasons that everyone's excited about it is for people to use RAGs. You can imagine if you're comparing your vector against 100,000, a million other vectors, that's going to take a long time. Vector stores do this way more efficiently, memory-wise, and way quicker. And that's one of the reasons that people use vector stores. Once you've created a cosine similarity for every document you have, every sub-document you have, you're going to now go and retrieve the chunks, the sections, the sub-documents that are most similar to your question. Question is, how many chunks do you take? I don't know. There's like no good answer. There's no real best practices. For my tool here, I chose 4 because that's like the default in LangChain. But I didn't have a good reason for that. One thing that people do is they sometimes represent and they retrieve the neighbor chunks. If you know that your kind of chunking and splitting mechanism was really good and got things well, you probably don't need to do that. But otherwise, you might want to, because what happens before and after might actually explain. The next thing you do is prompt engineer. Bring this all together. So here's what I did. This is my prompt here. I basically took everything and then asked ChatGPT and said, you are an assistant for question answering tasks. You need to answer questions about a YouTube video with the title, and then I gave it whatever title the specific video was. Use the following selections from the transcript as context to answer the question. Only answer based on the information included in the context below. If you don't know the answer, just say you don't know. Don't make anything up. Use 3 sentences maximum and keep the answer concise. At which point I had a little sort of a splitter, gave it the question, and then a little kind of identifier, and gave it the context, which was sort of just the concatenation of the parts, the transcripts of the YouTube video. I kind of like thinking about prompt engineering here, like talking to my 4-year-old. I have to say, ChatGPT, we're not going to be lying right now, right? I sometimes wish I could tell my 4-year-old, use 3 sentences maximum and keep the answer concise, but I don't. But ultimately, you can say that to your large language model. And this generates the output. This is sort of the question that I asked. I was also able to calculate how much it costs to run using ChatGPT 4. This time it costs 1.78 cents. GPT 3.5 is about 10 times cheaper, but it's not quite as good. So really for your use case, you can kind of decide whether you're going to pay the money or not. And then I like one of the things, again, I think is most important about RAG is because we've retrieved certain documents. You can go link back. You can say, because we've generated the document at minute 4, I'm going to show that video. Maybe you're using a PDF and you can say, I'm retrieved the chunk that's on the bottom half, page 57 of your HR document. And you can link to there or include that. And that's really a way to allow users to make sure that you're not hallucinating for them. I want to quickly also just show, I've got the code on GitHub. So if anybody is interested in this, you can take it, you can fork it, download it, look at it on your own. I've got this file, how to use Redux to save the embeddings as a pickle. I also had one version where I was using a vector store called ChromaDB, which is free and open source. So I've got using the YouTube transcripts API for that. The streamlit.py file has the actual kind of RAG and that prompt that I showed and anything else that goes on the screen. So you can kind of feel free to use it on your own. One thing I want to just quickly show you that I forgot to earlier. You know, you might have mentioned, you might have noticed in the prompt, I told it only answer based on the text that I'm about to show you. And that actually sort of causes or forces ChatGPT to forget most other stuff it knows. So when I asked it, who was the first president of the United States, when we talked about Streamlit and neurofibromatosis, they didn't say, and therefore ChatGPT doesn't know what the answer is based on the context, because I specifically said only answer based on the text that I'm giving you. The last thing, literally yesterday, Andrew Ng, who I mentioned earlier, made a course and put it online for free, how to build and evaluate advanced RAG applications. Again, this is a popular topic. If Andrew Ng is talking about it, uses Llama Index, which is a different Python package that also does RAG type stuff. You can use it for free. It explains more than what I just spoke about and kind of gives ways to give even more advanced stuff. I worked on this fairly quickly. There's lots of ways that I could have done an even better RAG tool. I could have maybe tried to use expert embeddings and fine-tuned it on my own. I could have tried to figure out some type of smarter chunking mechanism than just saying 1 minute. One thing that's actually pretty nice, in my tool, you have to choose which video you're asking. I probably could have made a way where you don't have to do that, and it knows based on your question which video you're going to ask. There's also some interesting stuff you can do with RAGs where you can have a compare and contrast. There's some tutorials online where you could take the financial statements of a company from 2 consecutive quarters and ask, how have the revenues and risks changed between the 2 quarters? The other thing for all of you who have used ChatGPT, one of the things that's most fun is the back and forth chat, where you say, ask something, it answers, and then you kind of have a conversation with it. I could have built in tools where you can ask a conversation, go back and forth. Right now, it's just sort of a one and done, but that's fairly easy to build in using prompt engineering. Obviously, I use ChatGPT. It's expensive. If I had access to some big GPU, I could have taken an open source model like Llama 2, and then I just pay for the compute instead of paying for the API. And that's the end. As a, just to remember, RAG is a great way to allow ChatGPT to answer questions about your documents. This is a QR code for the tool itself. The one thing I want to caution everybody is because I'm using the ChatGPT API, which costs money. I did not want to put my API key in there, so you can't all use my credit card information. But you can kind of use your own key. Anybody can get an API key. There's an area to put that in the sidebar. Don't worry, it doesn't store it, so I won't be taking your credit card information. And you can kind of put that in and then just use the tool as is. I have the code, I have the links to the slides, my contact information if you want to talk to me. And I think I'm going to pause here for any questions.
So have you heard of any other solutions besides RAG that could address this problem?
What do you mean by this problem?
Meaning help with hallucinations, kind of train it more specifically, the corpus that you want it to answer to, or I assume you could theoretically just train an entire language model from the ground up, but that would be extremely expensive.
Correct. So the question is, are there any other solutions besides RAG to deal with some of the hallucination problems? And there are. You sort of mentioned the big one, which is train your own language model, which is highly inefficient. I mean, for Meta, Facebook, when they trained Llama, they probably spent $10 million just on the training, not to think of however much money they spent on gathering the data. So, I mean, if you have $10 million, please let me know. But otherwise, you probably can't do that. What you can do sometimes is fine tune these language models. OpenAI now has a way where you can fine tune GPT 3.5, sort of the previous generation, with your data. You can give it a relatively small number of texts, and it will fine tune it for you. For one, that still costs money. You pay them to do it. I've heard people talk about it working really well. You're never going to do it for 4 documents. I think it's still an open question on which one is better. Most places that I've seen prefer RAGs unless you're talking about, say, at least a medium-sized amount of documents. You could also take something like Llama 2, which is open source, and fine-tune that yourself. But even then, you're going to be paying probably a fair amount of money of GPU compute because you can't run it on this computer.
I think a while back, Wolfram Alpha had like an engine. I mean, that's what it was, where it did like some basic text analysis to figure out what you want. And I think this predates like Transformers, but it just had a large data set. Like data bank that it kind of pulled all the answers from to get it. So I feel like if you can just, I don't know, there must be a way to like use embeddings to just like search directly.
So you were talking about sort of the idea of using embeddings to search directly into text. And I think that's definitely right. Why people want something like a RAG is for the final generation task, because they want, if you're going to just look for embeddings, all you're going to end up doing is extractive. So you're going to get only the exact text from your original texts. Here, this is able to combine them, reformat them, and specifically answer your question rather than just pulling out where the answer is. But you're right, like this isn't the only way. Like this isn't going to be used in every situation. There's lots of times in which you might just use the embeddings to kind of search on its own.
Yeah, so recently OpenAI allowed users to paste images into the ChatGPT window and search the images.
Yes.
All of your examples were with text. Well, could RAGs be applied to images or other type of media?
They could. I haven't. Well, I'm going to say they theoretically could. The tools that OpenAI are giving right now, I haven't seen them give embeddings for images. They're clearly using image embeddings in the background. They could decide to allow people to hit that API. You could use image embeddings probably from something like Stable Diffusion or other open source models. But if you're just going to try to use the OpenAI API, that feature isn't there yet, but there's no reason that they couldn't do that.
It was really great talk.
Thank you.
In your repo, which I will be checking out, can you tell me if you describe or have some examples of how you're returning the references that are retrieved so that you can like give your backup evidence of why it answered that, and how do you make it not look like some silly split? Like I use ChromaDB also. How do you make it not look like a really crappy split that's exactly 250 words or whatever?
So you asked how you how you can make a split that's good, that's useful.
No, I mean like I don't know. That's further out
Yeah.
for me. But like what I mean is like just if I want to demo a RAG and say here's a question based on something I don't know anything about, but here are the inputs that we made embeddings for. It retrieves something. Here's the reference material. How do you show those references in a reasonable way? Or do you have it?
So I don't have, what I have right now is just 1 minute chunks. So like what might happen is you might go find the video, start it, and first thing, you might think, oh, this doesn't answer my question because it's in the second 30 seconds. So you might need to be a little patient. I don't think there's an amazing way to do that right now. I think I'm going to suggest, if you're interested, go to that Andrew Ng course. I saw some talk about
Yesterday. I know what you're talking about. I watched the first two with the two other guys.
Yeah. So they talk about that online. I know a lot of the talks that they do is try to use very small chunks, like as short as possible, essentially like one sentence, and then embed those. And then when you bring it into the generator, you use a lot of neighbors before and after. But if you're showing the proof, you just show the originally retrieved sentence. That's, I think, one of the suggested ways in Llama Index. I can't say I've used it to know whether that is a good way or not, but that's, I think, one of the ways that is used. Sorry, I don't know if I repeated the question, but essentially, the question was, how do you, when you want to show at the end, these chunks are often very kind of weird at the end, maybe includes too much information, and how do you just show the part that is relevant? And I said the suggestion online is often to use as small slices as possible for your retrieval and use a wider set for the generation. I'm not 100% sure that's a perfect method in all situations, but that might be a good start.
This data that you feed ChatGPT, does it become permanently embedded in its virtual memory? That's not the end of the question.
Yeah.
Could it be that somebody, in a different place at a different time asked this exact same question and get the information? And more generally, how do you secure this thing so that only people in your organization are able to use these embeddings and not nobody else?
So just to repeat the question, it's about the security risks inherent in ChatGPT. Specifically, are your questions kept and stored as embeddings? Can somebody else get your questions and answers? Specifically, the data that you uploaded. I will give you the official answer and the way people are thinking about it. The official answer is that If you're using the ChatGPT tool, they kind of say they probably will be keeping it. You can kind of sign in somewhere and give them your kind of code name, your like username, and they say if you tell them not to use it, they claim they won't. They also claim they won't use anything from the API. And here we're using the API, sort of the direct backend connection, and they claim they won't. As you can tell, I and probably most people are skeptical that that's true. We don't really know for sure. I'd say the two ways around it, the way we were using it when I was kind of working is one, in addition to the API, Microsoft, which is a 49% owner of OpenAI, has sort of copied everything. And you can use Microsoft Azure specific connections. And in general, people trusted Microsoft because they're a well-known company. And it would be quite the scandal if they did it. So people are trusting them a little bit more. The second way is if you're willing to pay for the compute, you can use an open source model. Facebook has open source Llama 2, which means if you have a computer, you can download it and the information will never get back to Meta. There's a number of other models that you can do. Again, the big cost is that this computer is not going to be able to run it. So you're going to have to deal with that and probably some complicated setup. But yes, there is a security risk, and you should never put into ChatGPT something that is highly secure. It's even still, it's very, very, very unlikely that it'll really come up. They have so much data and they're using so much kind of similarities that they're unlikely to be able to recreate your specific question. But if it's really important for you, like I would not put your name and social security number into ChatGPT. Yeah.
Just to kind of piggyback on what he was saying, there was a case of somebody who like put their picture into ChatGPT, and then it was actually getting leaked out in certain responses. So, I mean, I'm assuming they kind of got that together, but there are, you know.
No, that is a risk. There have been situations where data that you put in is leaked out. They're fairly rare, and you know, OpenAI is sort of every time that somebody finds a problem with it, they kind of come in afterwards and clamp down on it. So people find all these tools like hacks to like hack around it and get things out, and then they kind of close that. But it's very reactive rather than proactive. So again, there is a risk. In my example here, all the information is on YouTube anyway, so there's no secrets. But yes, if you're talking about your company's documents, you might want to use Azure. It might not be so scary if ChatGPT knows that your company gives 15 vacation days per employee, but maybe you have things that are a little more worrisome.
Yep. Two questions. First one short. We were talking about important parts of being a prompt engineer, and you went kind of quick. You said context inclusion and how to what?
And how to format your output. So you can essentially, again, if you're going to be using this within a tool, you can say, give it to me in JSON format. You can give it an example of the exact format you want to give it in. Maybe you want it in a CSV file, and it will then follow that for you, especially if you give it examples.
And then what was the purpose with the 15-second overlap when you were doing the transcripts? Why is overlap important?
So the reason that I used overlap is essentially if you have a 1 minute chunks and you don't have an overlap, somebody's answer to a question might be half in 1 minute and half in another. And therefore, that concept will never be captured in an embedding. So we're trying to create a situation where any sentence, any idea is going to be complete somewhere.
Could you explain what fine-tuning is and how that works?
So fine-tuning is a method used in any type of neural network. So not just text, not just NLP, not just sort of large language models. It's used in many machine learning methods in general, especially neural networks. So, okay, I'm going to get a little conceptual for a moment. Sorry, I don't have a diagram. So hopefully you can stay with me. But there's the way neural networks works is essentially it's levels of linear regressions or some type of connections between your input and your output. Sometimes you might have dozens or 100 hidden layers. So you put in an input of some text question. These were often used for image generation. Maybe it comes in as images, and each one is a different level. And there are numbers, parameters, sometimes called weights, which each one is predicting the next level. So you might have, I mean, some of these models have billions of parameters. What fine tuning does, so if you were to try to train your own model and you had 1,000 images or 1,000 texts and you had 1 billion parameters, you're not going to get very good results. But what you can do is take, say, the 7 billion parameters that are in the model and use your own labeled data. So maybe you're trying to classify something. Maybe you're trying to classify the topic of a text. What you can do is sort of fine tune it, which means you start with all the numbers and parameters that are there, and you take a certain segment of them and you tweak them in a way where it's training your model. It's starting off with what was there, what was trained on, I don't know, millions of documents. If Google made it, it's trained on, like, I don't know, all of Google searches or something like that. But you're sort of shifting them slightly to be based on your use case. And so let's say you wanted to fine tune it. I don't know, you are, I don't know, the US government, and you want to be able to build a specific large language model that's based on legislation there's been. Now, in the end of the day, legislation, I don't know, maybe you want to classify whether a proposed legislation is going to pass or not. I don't know, whatever. Legislation is its own kind of like method or type of text. And when you have something that's trained on legislation plus sports articles plus Reddit posts plus whatever, you can use your fine tuning to make your model a little more similar to understand the way a legislative documents work and how that understands words. And that might be able to be used for the answer. Does that at all answer your question?
Yeah, specifically, the input to fine tuning, is it, I think you answered this, is it generally labeled data? I mean,
so most of the time it would be labeled data to fine tune your model. These large language models are often trained on what's called sometimes semi-supervised or semi-labeled data, where what it does is it takes the text and it drops certain words, hides certain words, and it sees how well it could predict what word you dropped. So it sort of creates its own labeled data. So you could kind of use something like that to kind of fine tune it as well.
Okay. Well, if there are no other questions, let's give our speaker a round of applause.